Here we have two examples of finding the derivative of trigonometric functions. Part A says y equals sine x over the quantity 1 plus cos x, and we're asked to find y prime. So we just need to remember a couple of things here. The derivative of sine is cosine. The derivative of cosine is negative sine. And since we're working with a quotient, we'll need the quotient rule here. So let's go ahead and dive in using the quotient rule. So, okay, let's see, y prime then must be, okay, remember the quotient rule says, there's a lot of ways to state it, but we can say low d high minus high d low over the square, and away we go. So low d high, so low 1 plus cos x, d high, so derivative of sine x is cos x minus high sine x d low. Well, the derivative of 1 plus cos x, remember derivative of cosine is negative sine. So then we have negative sine x for that derivative of the bottom there. Okay, over the square, and away we go. So all over 1 plus cos x squared. Let's see if we can get some simplification here. I'm thinking we will be able to. Let's distribute this cosine through to both these terms up here. Well, that gives us, let's see, cos x plus cos squared x. Cos squared x. All right. And then negative sine x times negative sine x plus sine squared x. All right, so a lot of these just come down to a lot of trig identity simplification stuff at the end. All over 1 plus cos x squared. Again. Well, remember that cos squared x plus sine squared x equals 1. Right? All of this becomes 1. That's the Pythagorean identity. Okay, so that gives us cos x plus 1 all over, ooh, look at that, 1 plus cos x quantity squared. And we have even more cancellation here. Cancellation is always the best part right at the end. There we go. The whole numerator cancels out with one of those, and the denominator leaving us with 1 over 1 plus cos x for our final answer, and there is the derivative using the quotient rule. Okay, for part B we have y equals the quantity sine x plus cos x all over e to the x, and we're asked to find y prime. Why don't you pause the video, try this on your own, use the quotient rule, and see what you get, and then we'll compare notes. Okay, so let's do it here. We have y prime equals, okay, quotient rule again, low d high. So low is just e to the x times the derivative of high. So derivative of sine x, if you recall, is cosine x. Derivative of cosine x is negative sine x. So there's low d high minus high d low. So sine x plus cos x, we just leave that alone. D low. Remember, the derivative of e to the x is e to the x again. It's the world famous function that has itself as its derivative. Okay, over the square and away we go. So e to the x squared, I'm going to write that as e to the 2x. Okay, well, we're done with the calculus. The calculus is always the easy part. The algebra and trigonometry are, in this case, and often in all cases, the more challenging parts of the calculation here. So let's see what we can make happen. I'm going to factor an e to the x out to the front. Because look, that'll cancel with the stuff in the denominator. That's kind of nice. We have e to the 2x down here, so those will cancel. But what do we have left if I do that? So we have cos x minus sine x. And then this negative up here gets distributed through. So we have minus sine x again, minus cos x. Well, look at that. Our cos x's cancel, so that's kind of nice. I'm always down for a little bit of cancellation. And this e to the x up here will cancel one of these down here, since this is really e to the x squared. So we'll just get rid of the 2 down there. And let's bring this thing home. Looks like we have minus, how about minus 2 sine x over e to the x, which is a perfectly fine answer. That's fine. You can also write this as negative 2 e to the negative x sine x. Both of those answers would be just fine.